Okay, I pulled all my pieces out, set it up on this table. I remade my air box. I used to have this fan inside that housing. So what I did is adapted some 4-inch pipe into here and added some of that hot glue, and that's the wiring there. So the power supply be plugged in here where I'll be able to control the speed of the fan. So there it comes in. I was able to get this to fit. So this 2-inch goes into the 90 degree. That's going to be for the air spinning around the pipe here. I've got two systems in here. So this here, I got it tapped off here. So this air goes into the center pipe. This air here goes around the center pipe. So what I have left to do, I need to cure this. Tomorrow I'm going to have to bake it in the oven. That's refractory cement, and that's going to go here to stabilize the copper pipe to center it. Then in the front, I may have to just put something under there, a piece of fire brick, just to keep it relatively centered. So you got a little bit of gap in there. So when I get this ready to fire up, I'll take this part off, and just the copper pipe would be going through. And I'm probably going to have to put the swirl device about here, right? So the propane and air, I put a propane tap there. The propane and air will come in here, and it would go through the swirl device, and you'll be able to see this heat up. Okay, then to test this pipe here separate, I'll simply pull this out, and I'll stick that in. So I'm actually back to the basic operation. So I'll be testing the center pipe here. I'll be testing this here, the outer pipe. So when you test the outer pipe, your propane and air comes around this pipe here, and what it does, it kind of chatters around and goes back up and down, kind of like electrical flame. When it's inside here, it actually gets more of a vortex flame, but here it kind of chatters because it's in the process. It's not just thermal, there's partial electrical properties in this. So I'm going to do each one independently, then I like to fire them up both at the same time, and get this working. So after this test, I'll leave this mount on, but I'll separate this here, and I'll take this, and I'll put this into a vertical position, so it's straight up and down. But I may have to use a shorter pipe on this. And so this pipe here would actually go through the base plate. So we'd have a copper plate pipe going through the table and into the 5-gallon pail, whatever I'm going to use for, burning wood, plastic, or whatever. The gasifier may not be the best. It's going to be, fairly low end, because you need something that's really fabricated to actually produce your wood gas. When you're actually producing your gasification, you want as little air in the unit as possible, so that the unit charges up with wood gas, right? Or it could be gas off of a plastic, rubber, or whatever. It's all the same. It's just all hydrocarbons coming out. And that's it. Tomorrow I'm taking my break. It's the Sabbath, and I'll get back on this on Sunday. But the whole thing about this is to port the emissions, the raw emissions from the gasification, through this pipe here, and spin fire around the pipe. So this pipe is heated up to the red point, probably 1100 1200 degrees. So the core temperature should build up, maybe 13, 14, 1500 degrees. So as the emissions comes through the center pipe and comes out here, they should be fairly well cracked. I may have to put some kind of catalyst here to speed up the reaction. So between the adding the gasification to the propane burn, I'm hoping for at least 50% gasification and 50% propane, right? And so you would be on par there. So you can actually make the units bigger, where you're producing maybe 3 times, 4 times more syngas or producer gas or wood gas than the heat that's actually going into the pipe. But if this was actually complete, where I'm taking the gasification on the end there and putting it through a GEAT fuel processor to make compressible GEAT gas, I would be running all of this on GEAT gas, because with GEAT gas it's able to transmute all carbon into when you burn it, it produces a non-CO2 fuel, right? It breaks it down into the hydrogen state. So all carbon can be broken down into the hydrogen state using the GEAT fuel processor developed by Paul Pantone. Okay, going to end it here. I'm kind of tired, so I'll just show you the back side here. This is a 350 CFM fan, and I have my controller here where I can control the speed. So this is the first time that I've set up a double test like this with one pipe inside of another. It should prove interesting, but once I get this part perfected, and then I'll take this, I'll invert it and have this 1-inch copper pipe going through the table to charge it with go into a small 5-gallon pail where I could just put a bunch of stuff in there and light it and see what happens. Okay, I'm going to end it here.